In section 3.5, you're going to learn how to take the derivative of trig functions, and most of these you just memorize. But on this first screen, I'm going to try to explain where the derivative comes from, and I'm going to explain it graphically here. So let's first identify the magic moments in sine, where it peaks, where it hits the 0. And there you go. It peaks at pi over 2. It hits the x-axis at 0, pi, and 2 pi. And the sine curve bottoms out. It hits a minimum at 3 pi over 2. Completes its cycle, its period, after 2 pi. All right, down below I filled out a chart. We're going to fill in the slopes of the tangent lines. That's what this y prime means. What is the slope of the tangent line? So let's start at the obvious ones. At pi over 2, the slope is 0. And it is also 0 at 3 pi over 2. So I'm going to fill those in down here. 0 and 0. Now the question is, what is the slope right here? A lot of students think it goes vertical right there, but it doesn't. It actually cuts through at a 45-degree angle, if you look at it closely, which is a slope of 1. So here we have a slope of 1, and here we have a slope of negative 1, down 1 over 1, and here we have another slope of 1. So let me fill those in. 1, 1, negative 1, 1. All right, now we're going to graph these points. Graph these points. So 0, 1, pi over 2, 0, pi, negative 1. 3 pi over 2 is 0. I'm just graphing these xy combinations. 2 pi, 1. Looks like a V shape, but we know that we can also draw a cosine curve through those dots, and that turns out to be the derivative. The derivative of sine is cosine, and I just sort of showed that graphically here. All right, let's move on. You'll be memorizing trig functions, and use my app or some flashcards I can print out for you to do things like this. And this is what the flashcard should say. The derivative of sine would be, and you turn it over, and on the other side would be cosine x. All right, let's move on. So let's go through these derivatives. These are things you just need to memorize. They're all in the book. The derivative of cosine, unfortunately, is not sine. It's negative sine. So you need to memorize that it's negative sine. The derivative of tangent is secant squared x, oddly enough. The derivative of cotangent x is negative cosecant squared x. So you see, I always kind of remember that the co goes with the cosecant. Tangent goes with just plain old secant. But they are both squared, and the co-functions tend to be negative. Like the derivative of cosine is negative, the derivative of cotangent is negative, and then the derivative of cosecant will also be negative. In fact, let me just fill that in right now while I'm talking about it. It's negative cosecant, oddly enough, cotangent. The product of those two things. Those are being multiplied together. The derivative of secant is positive secant tangent. And that's how you can answer the question in class. When I say, hey, what's the derivative of secant? You would say secant tangent. What's the derivative of cosecant? Negative cosecant cotangent. All right, let's move on. All right, so let's find a sample derivative here. Find y prime. I'm going to pause for a second because there's something special here. So think about, what is the special direction we have to go with this? Hopefully you said the product rule. We have to do the product rule, where the first is x squared and the second is cosecant. All right, so let's do this problem. The y prime is going to be the first times the derivative of the second. Now on the previous page we said the derivative of cosecant is negative cosecant x cotangent x, so I filled that in, plus the derivative of the first times the second untouched, cosecant x. So you could leave your answer like that, or you could write y prime equals 2x cosecant x minus x squared cosecant x cotangent x. Just looks a little nicer without having that minus sign out front. That's why I switched the terms around, and then I put that minus sign out front of the x squared. So on a multiple choice test, they might have this answer sitting there. All right, let's move on. Now this problem should look familiar. These were one of those sandwich theorem problems when we had to use limits. Well, the good news is we don't have to use a limit on this. We can actually find y prime directly. Now how do we do that? What's the special thing we need to remember here? I bet you all got it. We have to do the quotient rule, yes, our favorite ho-de high minus high-de ho over ho-ho. So remember, high is up high and ho is down low. So we're going to lead with the ho here. Ho d high, the derivative of tangent is secant squared x. How did I do that so quickly? Well, I've got them memorized, and you need to too. Minus high, then the derivative of the bottom would just be 1, d ho, all over the denominator squared. All right, so the final answer might be x secant squared x minus tangent x all over x squared. And that's what y prime would be. Okay, so you're basically just practicing with derivatives that you memorize and applying the same stuff we've been talking about. All right, let's look at a word problem involving harmonic motion. An object can swing back and forth thanks to modeling with a sine or cosine curve. So a weight hanging from a string is stretched 5 units beyond its rest. So at time equals 0, remember cosine is 1 at time equals 0. So this object at the start is 5. You should note that. So it's swinging, we bring it up to 5, and then it's going to swing. All right. And then it's going to swing back and forth. And gravity, of course, plays a role, but it will slow down when it gets to the highest point up here, and then turn around. Thanks to the cosine curve will help us model that. All right, let's find the velocity and acceleration functions. The velocity function would be the derivative of that, which would be, now it is a product, but remember, this is just a number out front, so we don't have to do the product rule here, people. All we have to do is write 5, and then the derivative of cosine is negative sine. So you just do that, and you're done. That's the derivative of the position function. And then the acceleration at any given time, because this thing goes back and forth, it does continually accelerate and decelerate and accelerate and decelerate. So we would expect yet another periodic function, a circular function, to be this acceleration function. And you take the derivative of velocity, and you get negative 5 times the derivative of sine, which is positive cosine. So we just tack on a cosine there, and there's the two answers. So that's all we had to do on this slide, was to find the two functions. And of course, if you needed to know, how fast was it going at time 0? Well, you plug in 0 here. Sine of 0 is 0. 0 times negative 5 is 0. So the initial velocity is 0 because we're taking it up here and we're holding it, and it's not moving at all. So it's got an initial velocity of 0. And then acceleration is pulling it down. Okay, so when you plug in 0 here, you get 1 times negative 5. It is pulling it in a negative direction, so it goes to the left here to start. All right, good luck on your homework. Should go quickly. Get those solutions up on Moodle if they're not already up there, and be sure to go through things carefully and make sure you know what you're doing. All right, good luck.